2 sludge reception silos, each with effective volume of 900 cubic meters, offers more than 2 days of storage capacity. Each silo is equipped with load cells which allow accurate weighing as well as precise metering of sludge feeding rate. Due to the limited land area, and in order to avoid the angle of repose inside the sludge reception silo, a network of distribution conveyors situated at the top of the sludge reception silo, along with a series of closed control sliding gates, allows for even distribution of sludge into the silos. Hydraulic-driven sliding frames along with speed-controlled extraction screw conveyor located at the outlet of the silo enables continuous feeding of sludge to the pre-dryers. Such configuration will prevent bridging of sludge in the silo. Raschka's sludge conveying concept includes the transportation of dewatered sludge in pipelines, which allows for additional heat recovery via pre-dryer exhaust steam condensation in jacket sludge pipelines. It also allows for additional redundancy because each dryer receives sludge from 2 sludge reception silos via separate sludge feeding line. In case one line is out of operation, the other remaining line is capable to feed the pre-dryer with full capacity. The system scores high in energy efficiency, increased reliability, and lower maintenance cost. 4 pre-dryers with 134% MCR capacity combined with the intercrossing conveyors after the pre-dryers allow the uninterrupted operation of the 2 incineration lines, even with 3 operational pre-dryers with any 1 pre-dryers down for service or maintenance. After the pre-dryers, a horizontal screw conveyor enables part of all of the sludge to be transported from each of the pre-dryers to any of the sludge silo, which means any of the sludge pre-dryers can serve any of the sludge incineration lines. With our proposed sludge storage, transportation and drying system configuration, we have come up with a robust operating system whereby any equipment in the system can be used to serve both sludge incineration lines. This means when any equipment is shut down for repair or maintenance, there is enough built-in redundancy in this system to ensure overall uninterrupted sludge incineration. Each incineration line is equipped with 2 pre-dried sludge buffers, whose bottom is fitted with several sludge conveyors preventing from sludge bridging in the buffer. 1 sludge buffer per incineration line with conveyors and spreader will be sufficient to support full incineration capacity for 1 line, which means the second buffer offers full redundancy. Odorous vent from the sludge reception silos is drafted to a dedicated nozzle on incinerator by a dedicated fan to avoid smelly substance accumulation in windbox. Hot ambient air collected at the top of the fluidized bed incinerator will be fed to the inlet of the combustion air fan. By such a setup, odor gas releasing to the environment is prevented and the heat dissipated to air by incinerator is recovered to a high degree. A 2-stage heat exchanger is implemented to recover the heat from pre-dryer exhaust steam and preheat combustion air to 120 degrees Celsius before it is sent to the boiler for further heating. The Raschka fluidized bed incinerator is a steel casing with an inner refractory lining and an outer thermal insulation. The main sections are the wind box with the heating up combustion chamber, the nozzle bottom, the fluidized bed area, the cylindrical freeboard, and the upper part with the flue gas outlet. 2 sludge spreaders are installed at the side of the steel casing. During startup, combustion air is heated by the startup burner, and freeboard burner provides additional energy into the FBI further. The hot air heats the fluidized sand and the entire furnace. The heating up is supported by special fuel injection lances mounted in the fluidized bed area. Startup phase ends when fluidized bed incinerator freeboard and head temperature exceeds 850 degrees Celsius, which is higher than the ignition temperature of the sewage sludge. The 2 Raschka spreaders distribute the sludge evenly across the fluidized bed. Nitrous oxide or laughing gas is a very harmful substance to the environment and typically generated at lower temperature incineration processes. With the increasing awareness of its harmful greenhouse gas effect and the support from the EU Environment Agency, most of the newly launched sludge incinerators projects in Germany now require 900 degrees Celsius freeboard temperature, with 4 seconds residence time in the fluidized bed incinerator in order to minimize the emission of nitrous oxide. To future-proof our system against the harmful greenhouse gas, Raschka's latest design enables the system to operate at a higher temperature of 900 degrees Celsius and 4 seconds residence time. The content of the fluidized bed may increase or decrease during operation, depending on the condition of the sludge received. A surplus of bed material can be discharged discontinuously during the operation by the Raschka bed material discharge device, which is connected to the fluidized bed incinerator, followed by a water-cooled screw conveyor to reduce the temperature to safe levels. In case of a decrease of bed material, silica sand is fed into the incinerator. Provision for an SNCR system will be made to future-proof the system for very low NOx emission. In Raschka's proposal, a compact and high-efficient boiler system is applied. The first empty pass formed by membrane wall cater for highest heat exchange efficiency by radiation heat transfer. High-temperature gas-to-gas heat exchangers installed in boiler second pass enable to heat the combustion air up to 500 degrees Celsius for all load points if needed. Proven design of boiler passes, high-temperature air preheater, superheater, evaporators and economizers will have adequate flue gas speed to make the boiler self-cleaning. An electrostatic precipitator is equipped at downstream of the boiler. The electrostatic precipitator provides more than 99% dust removal efficiency and residual dust level, with less than 100 mg per normal cubic meter at the outlet is guaranteed. A baghouse filter is equipped after electrostatic precipitator. The dust in the flue gas will be reduced further in the baghouse filter. The baghouse filter provides more than 99.9% dust removal efficiency and residual dust level less than 5 mg per normal cubic meter at the outlet is guaranteed. 4 electrostatic precipitator ash silos allow more than 96 hours buffer of electrostatic precipitator ash. And 2 baghouse filter ash silos form a common baghouse filter ash storage, allow more than 300 hours buffer for baghouse filter ash. Configuration of ash transportation system allows ash to be discharged to truck container humidified or non-humidified. A low-temperature economizer is equipped at the outlet of baghouse filter. This economizer is used to heat boiler, feed water and combustion air indirectly to prevent dew point corrosion. A quench at the top of hydrochloric acid scrubber enables rapid cooling down of the flue gas before entering into the hydrochloric acid scrubber. An acid scrubber and a caustic scrubber will ensure adequate removal of hydrochloric acid and sulfur dioxide in the flue gas. ID fan, installed after caustic scrubber, ensures the -5 millibar required in the fluidized bed incinerator and is designed to overcome the pressure drop for maximum possible flue gas flow, plus sufficient safety margin. A flue gas reheater installed after ID fan will avoid any white smoke at the sac outlet. An activated carbon absorber installed after flue gas reheater allows removing any heavy metals such as mercury from flue gas. Raschka's technology for sludge pre-drying and sludge incineration with state-of-the-art flue gas cleaning system, which is capable of complying with EU and NEA's emission requirements. Raschka's technology guarantees a safe, sustainable, highly efficient and environmentally friendly way to handle and treat sewage sludge.